resistance training are the cardiorespiratory adaptations. So we're getting back into kind of my wheelhouse here. So same objectives as the previous videos, only we're focusing on the cardiorespiratory. Okay, so I want you to think for a minute, what happens to your cardiovascular system when you exercise, when you're doing resistance training, so when you're lifting weights or something like that? Hopefully you thought of things like this: increased heart rate, increased stroke volume, increased mean arterial pressure, increased cardiac output. And really, if you remember, we've got this equation, right? So pressure, mean arterial pressure, equals heart rate times stroke volume times resistance, right? We don't have resistance in here, but we're going to have an increase in resistance. We're going to have that fight or flight response. If we increase any of these variables, any or all these variables, we lead to an increase in pressure. So that should make sense. So that's acute, what happens. So what happens chronically? Well, there is some evidence to suggest that that there are changes in resting heart rate, but it's not as pronounced as aerobic training. We're going to have lower pressure, so that's good. We're going to have a decreased rate pressure product, which you've talked about in lab. So that's heart rate times systolic blood pressure. Gives you an idea of how hard the heart's actually working. And so this is good. The heart's going to adapt, so it's not working as hard. And we get that. We also get increased ventricular wall thickness, which allows the heart to contract harder, so it's more efficient. Additionally, we're going to have smaller changes in heart rate and blood pressure during exercise. Okay, but just ignore this line here. There's no change in oxygen extraction. So why is that? Why don't we change the amount of oxygen that we're taking up? Well, remember, with resistance and anaerobic training, we're doing these explosive, short, high-intensity movements that don't really require oxygen, so there's no benefit to extracting more oxygen when I'm relying on the ATP, PCR, and the glycolytic systems. So from a respiratory side of things, almost really to the exact same or similar to aerobic exercise, ventilation is rarely, if ever, a limiting factor during exercise. When you start to do this aerobic training or anaerobic training, resistance training, your ventilation increases during exercise, right? So you're lifting weights. Even though there's an anaerobic response, you're still going to increase your ventilation. Now, chronically, what's going to happen is that you're going to increase tidal volume and decrease respiratory rate during submax exercise. This should sound familiar, and it is, because it's the same response that we get from aerobic training. And so as a result, we have greater tidal volume and even an increased respiratory rate during max exercise, which means we can bring more oxygen in. And this is ultimately improving our ventilatory efficiency. It's a measure called VeVO2, or ventilation divided by oxygen uptake. Okay, and so if we improve this, this means that for every liter of air that we bring into our bodies, we're taking in more oxygen, a higher number, we want to be more efficient, right? So those are some of the chronic responses. And so that is how we're going to end the anaerobic or resistance training unit.